Dr. Atchison here, and we're talking about Chapter 8. We're in our second lecture discussing the core knowledge approach. So the core knowledge approach is a domain-specific knowledge system, and that means that it applies to a single topic. So basically what they're saying is that infants have some basic knowledge prior to learning from the environment. So while both Piaget, Vygotsky, and the information processing system is talking about learning from the environment, core knowledge perspective is saying, no, some of this is innate. Some of this, they really have some basic knowledge, or at least a basic knowledge system, and that these basic knowledge systems are domain specific. What domain specific means is that change in one ability doesn't affect the other areas of development. So this is very different, again, than that dynamic systems perspective that was more domain general, that abilities that affect multiple aspects of development, such as the other things we've discussed in information processing, like memory capacity. Domain-specific abilities is, again, restricted to that domain. And core knowledge perspective says that there are certain domains about the physical and the social environment that, again, appears to be inborn, and these are there for adaptive purposes, and that has helped for the evolution of the species. So this was first brought up by Spelke, and it really came out of work with objects. So the first kinds of core knowledge ideas that were put forth were about continuity and solidity, cohesiveness and collisions. That's going to have to do with physical causality. But it's coming out of Spelke and was based on this idea that these really, really young infants, like 2.5 months, seemed to know about some of these kind of processes. They again did it with 4 and 6 months. And again, they saw these really, really early abilities. And that sparked Spelke to talk about this as this core knowledge, this kind of innate understanding about the physical, and later on they added the social world. In this theory, there's no qualitative change. So the change, there's not that you develop an ability to then learn more. There's not a qualitative change in the system. You might have a quantitative change about how much you know, but there's not a qualitative change. So the quality of your knowledge doesn't change. And according to this perspective, cognition really has its own origins, and it's not derived from perception and action. So again, this is very much the opposite of Piaget. It says, hey, everything is from this action and perception of the environment around us. Core knowledge is pretty much the polar opposite of that. It's also very opposite to Vygotsky. Vygotsky is going to say that you're learning everything from your environment through social interactions with your environment. And again, core knowledge is saying, no, some of this stuff is really is born, that infants are born with. So now let's go through and talk about these specific domains and some of the support that they have for their theory. So the specific domains that we're going to talk about, and again, this means same thing as domain specific, that they know about these different domains of knowledge, and that knowledge about one doesn't influence the knowledge about the other, that again, there's no qualitative differences within these domains of knowledge as going on through development. And we're going to talk about each of these in more detail. So there's solidarity, that things maintain a solid form. There's continuity. This is going to be related to that object permanence we talked about with Piaget. There's causality. This is how objects interact with each other. Social world. This is the infant's interactions with others. Human behavior. Understanding how people are different from objects, and also psychological states. So the first three were kind of the foundational pieces of core knowledge theory that Spelke started with. And later the theory was adapted to include these innate knowledge of the social world and human behavior, and psychological states. Okay, so solidarity is again this idea that an object is going to maintain a solid form, that the form of an object is constant, okay? If you haven't already, pause this video, go back and watch those core knowledge domain videos that are posted on D2L. They're also on the YouTube playlist as well. And they talk about each of these videos. So you can see how the evidence supports these. Some of this comes through work by Andrea Aguiar, who did a video on did a study on object properties, and you can see that in the video, where again there's a difference between the size of one object and the size of another object, yet it appears that the larger object is going into the smaller object, and infants in these violation of expectation studies are surprised by this. And again, core knowledge perspective is going to say this is support that the infants believe that objects really maintain a solid form and are not able to change form, so that again, that this is not learned through environment, that this is innate knowledge. The second domain is continuity, that an object continues to exist outside even when you can't see it. So again, a lot of support came out of Balarajan's work with the violation of expectation studies that we talked about in chapter 7 with object permanence. So where they were hiding the ball or the box behind the screen, all of those occlusion tasks really, again, and we were seeing very, very young infants passing these. So again, the core knowledge perspective is going to say, this is support for the fact that infants innately know that an object continues to exist. Additional work comes through Karen Wynn. She also did a violation of expectation task, and she added on to it, literally. She did some basic addition and subtraction with objects, and infants were surprised when they saw a mathematical equation that didn't work. So if you had two dolls, you had two Mickey Mouse dolls, you took one Mickey Mouse doll away, the screen went down, and there's two Mickey Mouse dolls. Well, that doesn't compute. 2 minus 1 doesn't equal 2, and infants were surprised by that. So Karen Wynn really expanded on this core knowledge and said that she actually believes that infants have an innate number concepts that are part of this core knowledge. And this is supported by work not just from Karen Wynn, but others as well. She says, we see this from work that infants are able to discriminate one circle from 4 circles. And this is work that was done by Elizabeth Brannon that again supports the idea that they know that 4 is more than 1. And so again, this innate idea of number sense, that how many things are and that you can change those amounts. They're not saying that they know 2 minus 1 equals 1. They're saying this amount minus this amount should be less than it started with. So it's not necessarily like our understanding of math, but it is that basic concept of number as more of an innate concept. Again, Wynn really has this nativist view. She says that infants understand numerical value of a small collections of objects. They're not going to be able to do like 100 minus 2 and go, oh, well, that's supposed to be different. We're talking about small collections of objects. And they're saying this view also says that infants can apply this to different items and different modalities. So it's not specific to objects, that it can be applied to different modalities as well. And that they can reason at the ordinal level and compute simple arithmetic problems. And we'll talk about the ordinal level in just a second. Now, just like with any theory, there's people that go, I'm not so sure about that. And so there's definitely some alternative interpretations for Wynn studies. And again, go and watch that Wynn video if you haven't already. It's a very good video. Some of those alternative interpretations are that it's really more the perceptual properties that are causing these changes in perception, not really an innate sense of number. So the idea that those 2 Mickey Mouse dolls have more space that is occupied with 2 than they do with 1. And so it wasn't an issue of number per se, but that it's more an issue of kind of contour. So those outside boundaries of those objects, that is the difference. There's also the alternative interpretation of that it's directional. They understand that something should be more, but they're not necessarily sure how much more. So you should have more of something, you should have less of something, but that there's not this innate concept of number that they should know it's exactly how much more it is. And again, there's an information processing approach too, which is one of the reasons that your book puts these two juxtaposed against each other, because they're they're looking at the same kinds of processes from very, very different ends of the spectrum. And Cohen and Marks would say, well, they're just looking longer at things that are more familiar to them, that it really has more to do with just how they're processing information than it does have to do with the understanding of number concepts. So let's talk about some things we actually do know about number concepts. Ordinality is the relationship between quantities. So the idea, again, that 3 is more than 2. We see this really, we have lots of evidence that this really approaches about 14 to 16 months, not really much earlier than that. Again, when studies are showing earlier than that, everybody agrees by 14 and 6-month-olds can do it. The earlier age ranges, there's disagreement about what's going on in those studies. Cardinality is that when the last number in a counting sequence indicates how many there are. So if you count something and you get to 10, there's 10 of something. If you count another group of something and you get to 15, there's 15 of something. So again, that when you count to 10, that's how many of them there are. We don't see this really emerging, again, where everybody's agreeing on it, so about 3.5 and 4. So here are some videos that kind of show you some differences in counting on both ordinality and cardinality, but primarily cardinality in these next two.
Can you count for me?
2.
Oh, here's more. Can you count?
1, 2, 8, 10, 2, 10, 10.
How many are there?
2, 8, 9, 2. I want rats.
So you can see there, she knew what the numbers were. She did not necessarily know what order they went in. She definitely did not have cardinality, that how many you got to is how many there were. And again, she didn't necessarily have ordinality really down yet very well either, from 0 to 10 at least. She could go 8, 9 and could kind of do that, but then she ended back up at 2. So again, there was definitely some issues. She was working on ordinality, definitely didn't have cardinality down. Here's the same little girl at 3.5 years, 3.5.
Now go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good job.
So you can see that time she had the 1-to-1 situation where there's one of something, we assign one number to it. In the previous video with the Play-Doh, she didn't necessarily have that. She also knew how many, when she got to 10, that she understood that there was 10 of those. Again, that's evidence that she finally got that cardinality down as well. And so again, these are things that we do know about infant and young children's number sense. But again, Wynne is saying that some of this is happening earlier. She's going to say things that are similar to the arguments against Piaget, that it's the task that's making children not be able to show their abilities earlier than they really are. So a task like this would be too hard for a young infant to engage in, so it looks like that they can't do it because the task is too difficult. It involves a lot of verbal differences. You could see in that first video when she was 27 months, that language, she was very vocal and very verbal for a 27-month-old, but by the same token, she was not at all a skilled speaker. And by 3.5, by 41 months, she had improved quite a bit. And so Wynne's going to say differences like this aren't due to her difference in understanding numbers per se. There's not that qualitative change. It's more about the task and showing that ability. We do know, again, things that we do know about numbers is that it really is experience-based, that the environment provides opportunities for number sense, opportunities for comparing quantities, and opportunities for talking about numbers. We see in those sorts of environments, in children and infants acquire skills earlier. So again, when children are presented this information, we see improvements long-term in their abilities. The same way, we'll see that puzzles will improve spatial knowledge and math skills. And so you hear all the time that you should be reading to infants from birth because it's really beneficial. It's giving them this experience that will kind of the input affects the output. We'll get better output if we put more input in earlier. We're really finding that numbers are the same thing. That talking about numbers earlier really improves math skills long term. To that end, there's a website called bedtimemath.org, and it's the exact idea as bedtime story, except it's like little mini math problems, and they have them for very young children, kind of 2-year-olds who are verbal. They have them for preschoolers, and they have them for older children. And it's just one's kind of simple. Usually there's a little story or something interesting that goes along with it, and then there's a question that children can answer. With, again, the same idea is by comparing these quantities, by talking about number concepts, that we're really improving the environment and we'll get better numbers outside. Okay, so back to the core knowledge domains. Now we're talking about causality, and this is how objects interact with each other. So again, there's a video I'd like you to watch from Rachel Keene looking at double occlusion. And this is the idea that inanimate objects can only interact through direct contact. So I can't make something inanimate move unless it has direct contact with something else. The pins at the end of the bowling lane aren't going to fall down until my ball hits them. They need to have direct contact through something else for them to be able to move. And again, that Rachel Keene video talks about which of those abilities they believe are innate and which of those abilities are going to be more kind of additive, quantitative changes rather than qualitative changes. Again, the new domains that they talk about in core knowledge are that this innate understanding of the social world and the innate interactions with others. I know we talked about a little bit in class, neonatal imitation. Here's a great video that will show you that. And again, core knowledge perspective is going to say, see, this is evidence that this is inborn, that this knowledge is inborn. I discussed it in class in terms of a mirror neuron system, and there's, again, a lot of support for that as well. The core knowledge perspective is not one that I necessarily adhere to. I love a lot of their research studies. They're great, beautiful studies. I just come to very different conclusions from their studies than they do. But again, the core knowledge perspective is going to say that this neonatal imitation is indicative of this inborn knowledge about how to interact with others. They're also going to say that there's inborn knowledge about understanding how people are different from objects, and that people have intentions. And so the study that's talked about in your book as related to understanding human behavior is actually this intentions video from Amanda Woodward. So watch that because you can see how your book discusses it and you can actually see the study played out. And finally, their last domain of core knowledge they're going to say is that infants have an innate understanding of psychological states. This includes things like joint attention and social referencing, and there's videos for both of those. Joint attention is when I attend to something, I look at something, and because of that, somebody else is going to look at the same thing. So if I'm talking to you and I'm having a conversation, I all of a sudden stop and look to the left, you will probably stop and look to your right. You will look at the same direction that I'm looking to see what I'm looking at. That's joint attention. And again, they're going to say that infants kind of have an innate understanding of this. And that this joint attention is really going to allow for social referencing. That is agreed upon on both sides of the debate on core knowledge, that social referencing is a byproduct of joint attention. Social referencing is when we can look at someone else's reaction to something and determine how we should react to something. And again, there's a video. And in this video, there's kind of two different trains. The first train, the mother responds positively, and the infant goes to check it out. The second train, the mother kind of acts scared, and the child does not go check it out. So again, they both have joint attention to these trains. The child looks to their mother to figure out, what am I supposed to do with that? And uses those social cues to make determinations about whether this is something that's safe, whether this is something that's interesting, how they should interact with this new novel thing. And another psychological state that they talk about is that children have an inborn understanding of intention and desires of knowledge of others. And they will point to studies like the broccoli cracker study that's both discussed in your book, and that is also a video that I would like you to watch. And they will also discuss things that are similar to Balarajan's Understanding False Belief video that I'd also like you to watch. If you've noticed, I've kind of gone quickly through these different states because the evidence that supports them are best shown, I believe, through those videos. So really go and watch all of those videos, and you can look at them with your lecture outline so you can see kind of what we're talking about together and what kind of support they have for these innate ideas of these innate domains of knowledge. Just like with any theory, there's criticisms of that. Some of that is that these are inadequate research methods. They're saying that what they're testing, what they think they're testing is not necessarily what they're testing. Or those behaviors are not indicative of what they think they are. Remember, information processing is really good about breaking things down into tiny little pieces and looking at those tiny little pieces. And so the information processing people are going to say, well, you didn't do that here. That could be any number of things, such as the difference in numbers, the contour length, how much space it takes up. And in fact, they've done studies where there's differences, the amount of space the things take up are the same, but the numbers are different. And we don't see infants differentiating between those then, which really supports the idea that it really is about the amount of space that these things are taking up and not necessarily about an innate understanding of knowledge, of number, I'm sorry. There's also a question of built-in knowledge due to what we understand about the brain's plasticity, that the brain is plastic, that the brain is adaptable to change, that the brain is adaptable to its environment. Well, then why? Why is it adaptable to its environment if there's no qualitative changes? If we have all these domains of knowledge and we're inborn, then why isn't our brain just done and ready to go and everybody's brain has the same level of abilities? We don't have that. And so again, that's going to be a major criticism of core knowledge as well. And finally, well, if we have all this built in, then what's going on with all these developmental changes that we see? Clearly, a newborn is very different from a 2-year-old. If there's no qualitative changes in their understanding of number between birth or their understanding of human behavior or their understanding of solidity or solidity, and their understanding of physical causality, if there's no qualitative changes in this, then what is going on? How are these changes that we see in development? What are those then if they're not qualitative changes? So this sums up our conversation on core knowledge. Again, watch all those videos. They have really fun studies. It's again, the criticism comes, well, but are you studying what you think you're studying? Disagreeing about operational definition, disagreeing about what actually is being studied. So go back and watch all those videos with, if you haven't already, with the lecture outline so you can match the support for that domain up to its research. Thanks.